Okay, spring 2026 Gen Chem 1 students. I'm here with our second AI assignment, Unit 2. Once again, when I went into Dot struggled to keep this within the bounds of Unit 2. So you may be running into things that ask you to draw water molecules, draw other types of structures, when this is a bit beyond the scope of what Unit 2 covers. So do try to manage how Dot gives you assignments, and when you can't keep it in boundaries, use your discretion at which problems to solve. I've decided to go through this conceptual problem with you for Unit 2, where it says, sketch a diagram illustrating the ionic bond formation between magnesium ions, Mg2+, and nitride ions, N3-. Well, the illustrative way that I want to show this is actually the box method. What I'll do here for the box method is I'll show each ion in a box, and next to it I'll split the charges across these boxes. Magnesium will have 2 at +1, and nitride will have 3 negative ones. We can see that although my boxes look to be sized appropriately, they actually don't cancel each other out. The magnesium and the nitride are imbalanced 1-to-1. So in order to have an equal number of positive to negative charges, the box method will show me that I need to have some other number, I apologize for that, some other number of ions ratioed together. So what I'm going to do here is try to get to the lowest common denominator. I can get 2 up to 6+, and I can get 3 up to 6-. But to do that, I will need 3 magnesiums, and I'll need 2 nitrides. So I'm going to draw another box here for a second nitride ion, which again brings with it 3 negative charges. I'll draw in a second Mg2+ ion. This has not quite balanced out, and so I draw my third Mg2+ ion. And now I have a perfect ratio. For every positive, there is a negative charge, and so my ions are completely balanced. For this reason, we say that magnesium nitride has a chemical formula, Mg3N2. I need 2 nitrides to balance the charges from 3 magnesiums. These subscripts help me communicate how much of each ion is needed. Down below, it has given me, I asked it to look for the learning objectives on communicating the names of compounds based on their chemical formulas and writing chemical formulas based on their names. To be quite fair, I don't really like what AI has given me for examples, but again, this is an assignment that is meant to help you put pen to paper and do some productive struggle. And so I didn't want to spend too long trying to whip AI into giving me the problems that I wanted. So I took the ones that it gave me. I'm going to solve a few of them. I'm ignoring the ones that are either so easy I think you can solve them on your own, highlighting a few that have interesting problems, or I'm ignoring some that maybe go beyond the scope of this assignment, like showing the charge distribution in a polyatomic ion. So we're given the polyatomic ion carbonate, and it's asking us to write the chemical formula for the compound lithium carbonate. Well, lithium has a +1 charge. Carbonate with a 2- charge means they won't be balanced 1-to-1. I can use the box method, and I find that I'll need 2 lithiums. Another method that I can use is the crisscross method. I use the charge of one ion to predict the subscript of the other ion. This tells me lithium predicts one carbonate and carbonate predicts two lithiums. So I'll write Li2CO3. That is a subscript 2 on lithium, and carbonate appears as one component. It also wants me to name a molecular compound, sulfur and oxygen in the compound sulfur dioxide. You'll notice that this has a prefix in front of oxide. That prefix informs you that it is not ionic. Ionic doesn't need any prefixes to inform of how many ions are needed because the ions are present based on their charges. In molecular compounds, they are not present based on their charge, so they can be present to varying amounts. Di tells me 2 of my oxygens. The fact that there is no mono in front of sulfur tells me that it is 1, but we assume mono for the first compound. So 1 sulfur, 2 oxygens, SO2. I also wanted to go through the polyatomic ionic compound calcium hydroxide. That is calcium 2+, and hydroxide minus. Once again, the crisscross method or the box method will help me predict how many of each to have. So this time, I want to have 1 calcium, and I'll show this by the box method. And I'm going to need to have 2 hydroxides. In writing the chemical formula for 2 hydroxides, I will need to use a subscript that informs that both atoms of my polyatomic ion are present twice. So I lock my hydroxide in parentheses and use the parentheses to inform that there are 2 of everything included in that parentheses. This is very, very different from writing a chemical formula as CaO2H2. O2H2 is hydrogen peroxide, and it does not form ionic bonds with calcium. The parentheses here are very necessary. Now I want to take a step back because some people will take this to say every ionic compound, polyatomic ion rather, needs parentheses. But really that's not true. If something is only present once, we don't put parentheses around it because it's assumed to be only once. There is no parentheses for a subscript 1. So if a polyatomic ion is present once, no parentheses. If a polyatomic ion is present twice, parentheses around all of those atoms. Now, I put together this table for you. It's not incredibly exhaustive, and you might notice that there's some weird spots here, but I've tried to highlight certain chemical species that are in the same family, such as bicarbonate and carbonate, bisulfate and sulfate, bisulfite and sulfite, dihydrogen phosphate, hydrogen phosphate, and phosphate. These are many of your monoatomic and polyatomic ions. They've been split from left to right by cations, positively charged, and anions, negatively charged. What I would encourage you to do is to form as many combinations of ions possible. Now, for any of you out there that like math, this is a lot of ionic combinations. You can write lithium with each of the -1 ions to get lithium fluoride, lithium chloride, lithium bromide, lithium iodide, lithium nitrate, lithium nitrite, lithium hypochlorite, lithium chlorite, lithium chlorate, lithium perchlorate, and lithium azide. Lithium acetate, lithium hydroxide, lithium bisulfite, lithium bisulfate, lithium bicarbonate, lithium manganate, lithium hypobromite, lithium bromite. Okay, do I have to keep going? They keep going and going and going. What I would definitely encourage is that you take an example of a +1 ion with a -1 ion and show a compound that it can make. Take an example of a +1 ion and a -2 ion. Take an example of a +1 ion and a -3 ion. And then change the charge of your positive ion. And watch how your chemical formulas change as you go. You'll notice that the subscripts have some consistency between them, and you'll start to notice better patterns in your naming and your ability to draw ionic compounds. There's an endless possibility here, but start with these 9. Start by taking a +1 and -1 ion, writing its chemical formula, writing its name. Then take a +3 and -3 ion and write their names. Now you'll notice that I don't have a lot of +3 ions. Iron 3+ is one of the most common +3 ions that forms. I suppose I probably would have been good to put in aluminum 3+ in there as well. What I would encourage is once you've used one +1 ion, don't use it again. Use a different +1 ion for the next. And each time, make sure that you use one of your polyatomic ions if present. This is a good exercise. And again, you may actually be able to use AI to help you coordinate between all of these different ions and coming up with examples for each type of combination. Keep up the good work and happy studying.